Okay, I hope I'm audible to all students who are attending this lecture for the ISI MSQE entrance. We continue with our discussion of the ISI PEB paper for the 2021 entrance. And if all students can recall that in the previous lecture, we had done our discussion for question 1. Now, in this particular lecture, I intend to discuss the second question for the PEB entrance for the year 2021. So let's look at question 2. It has two parts. The first part is for 12 marks and the second part is for 18 marks. You can see the distribution of marks on the screen. Okay. So let's look at the first part. Consider the following two variable optimization problem. Maximize x square plus y square subject to the following constraints. It's a constrained optimization problem. The constraints are x plus y less than equal to 1 and x and y greater than equal to 0. Find all the solutions of this optimization problem. Okay, so let's quickly come to the whiteboard and let's solve this part first. So we continue with our discussion of ISI PEB paper for 2021. And in this lecture, we intend to look at question 2. This is part A. Okay, objective is to maximize x square plus y square subject to the following constraints: x plus y less than equal to 1 and x and y greater than equal to 0. Now, guys, you can clearly see that the function is continuous. Okay, and if you plot the set, suppose I plot the set S. So I'm drawing a graph where I plot the set S. This is x, this is y. X and y greater than equal to 0 means first quadrant. Everything is in the first quadrant only. And x plus y less than equal to 1. So guys, if I plot x plus y equal to 1, when x is 0, y is 1. When y is 0, x is 1. So the line passes through 1, 0 and 0, 1. So this is my line x plus y equal to 1. And where will the shading happen? Where will the shading happen? So put x and y both as 0. So 0 plus 0 is less than equal to 1, true. So shading will be towards the origin. Shading will be towards the origin. So my feasible region will be this. This is my set S. Okay. You can clearly see that the set S is closed and bounded. Since the function is continuous, so I can say that let x square plus y square be equal to f of x comma y. Suppose I call x square plus y square as f of x comma y. So since f of x comma y equal to x square plus y square is continuous and the set S is closed. Closed means it includes all the boundary points, and bounded. Bounded means what? You can put the set S within a sufficiently large circle. Okay, so we had done this in our lectures on mathematical methods for economics part 2. Remember the extreme value theorem, EVT. We have done EVT, extreme value theorem, in our mathematical methods for economics part 2. And we are applying the same concept here. Since the function is continuous and the set S is closed and bounded, therefore, by extreme value theorem, there exists a maxima. By extreme value theorem, we can say that there exists a maxima. Now, first of all, we need to find the stationary point. So, what we are going to do is we are going to put the boundary. What is the boundary, guys? So I can say that at the boundary, x plus y is exactly equal to 1, which implies y is equal to 1 minus x. Putting this in the function. Putting this in the function f of xy. I get everything in terms of x, so I can write that f of x comma y will be equal to x square plus y square. But what is y, guys? 1 minus x. So let me call this as g of x, because it is entire. We have got it entirely in terms of x now. Okay. So I erase this particular part and I can write that my g of x is equal to x square plus 1 minus x square. Therefore, g dash x equal to 0 implies if I have to maximize g of x, I put g dash x equal to 0. That's my first order condition. So if I differentiate g of x, what do I get? 2x plus 2 times 1 minus x into 1 minus x derivative with respect to x is minus 1 equal to 0, which implies 2x minus 2 times 1 minus x is equal to 0, which implies 2x minus 2 plus 2x is equal to 0. So what do I get if I erase this particular part off? So this implies 4x minus 2 is equal to 0, which implies 4x is equal to 2, which implies x is equal to half. What was y? Y was equal to 1 minus x, which is equal to 1 minus half, which is equal to half. So half comma half is a point on the interior of the boundary. I can say on the boundary, I get the point half comma half. Okay, this is the point I get. Now, what do I have to do? I need to put all the boundary points in the function and check which is giving me the maximum. So we have just used EVT, guys, nothing else. So what are our boundary points? Our boundary points are 0, 0. 0, 0 is one boundary point. 0, 1 is another boundary point. Half, half is another point which we have got in the interior of the line. And then 1, 0 is another boundary point. So I need to check the value of the function x square plus y square at these 4 points. Okay, so hoping all students have understood. So now our job becomes very easy. I erase all this off. And now we can draw a table where we evaluate the function at these values. So we have the points and we have f of xy equal to x square plus y square. So our points are 0, 0, 0, 1, 1, 0 and half, half. If I put 0, 0, I get 0. If I put 0, 1, I get 1. If I put 1, 0, I get 1. If I put half, half, I get 1 by 4 plus 1 by 4, which is 2 by 4, which is half. So where is my function coming out to be maximum? This is the maximum value. And this is also another maximum value. So all students can clearly see that the function is having a maxima at 0, 1 and 1, 0. So the answer for this question I can write that f of xy has a maxima at 1, 0 and 0, 1. And the maximum value is equal to 1. This is the final answer for this question. F of xy has a maxima at 1, 0 and 0, 1, and the maximum value of the function is exactly equal to 1. So hoping all students have understood question 2 part A. Okay. Now let's come back to the paper and let's read part B. So part B, it's a big paragraph. Let's quickly read it and then we can try and solve this one as well. Okay. So in a kingdom far away, a king is in the habit of inviting 1,000 senators to his annual party. As a tradition, each senator brings the king a bottle of wine. So there are 1,000 senators and every senator brings a bottle of wine. So the king receives 1,000 bottles of wine. Okay. Then One year, the queen discovers that one of the senators is trying to assassinate the king by giving him a bottle of poisoned wine. Unfortunately, they do not know which senator nor which bottle of wine is poisoned, and the poison is completely indiscernible. That means the bottle of wine, you can't look at the bottle and see that this contains the poison. That means the poison is completely within the wine, and the poisoned wine is not showing any other smell or any other color as compared to other wines. That means you can't look at the wine and see that this is poison. Okay, the poison is not affecting the color and the taste and the smell of the wine. Okay, then the king has 10 prisoners he plans to execute. He decides to use them as taste testers to determine which bottle of wine contains the poison. The poison, when taken, has no effect on the prisoner until exactly 24 hours later, when the infected prisoner suddenly dies. The king needs to determine which bottle of wine is poisoned by tomorrow so that the festivities can continue as planned. Hence, he only has time for one round of testing. How can the king administer the wine to the prisoners to ensure that 24 hours from now, he is guaranteed to have found the poisoned wine bottle? So it's a very interesting question, okay? And now we need to actually, as mathematicians, how do we look at this question? Now, king needs to design a function, basically. The king needs to design a function as to how he can administer the wines. He has received 1,000 wines from 1,000 senators. Now, how can he distribute those 1,000 wines among 10 prisoners so that he comes to know 24 hours from now, from the death of one of the prisoners, as to which wine was poisoned? Okay, so somewhat it's like a function. If you look at the question, it's like a function with domain and codomain. So let's come to the whiteboard and let's solve this question. Question 2, part B. Okay, so first of all, let's quickly try and make some sets, okay, which help us to solve this question. So I can say that let W denote the set of bottles of wine. Let W denote the set of bottles of wine, and P, since we are denoting prisoners by P, so P denote the set of prisoners. Because ultimately the objective is to give wine as taste tester to the prisoners to see if the wine is poisoned or not. So if I write them in the roster form, guys, how many wines we have? We have 1,000 wines. And how many prisoners do we have? We have only 10 prisoners. Okay, so I can at the same time write that if you look at the cardinality of this set is 1,000 and the cardinality of this set is 10. Cardinality means the number of elements in the set. Okay, so far it's clear. Now, what do we need to do? So we now need to find a way in which 1,000 bottles of wine can be administered, or can be allocated to 10 prisoners so that the poisoned wine bottle can be uniquely identified based on the prisoners who die after 24 hours. So we need to see how we can distribute 1000 bottles of wine among 10 prisoners so that you can see from the death of the prisoners as to which wine was poisoned. Now understand this, guys, there are 10 prisoners. Now, and how many wines have to be given? 1000 wines have to be given. Now, understand this. When you have 10 prisoners, what are the possible groups you can make? In other words, what am I heading at? The possible groups you can make is number of subsets only. So what are the number of subsets of P? I can write total number of subsets of P. So total number of subsets of P is nothing but 2 to the power the cardinality of P. That means how many elements are there in the set P? 10 elements are there. Okay, I can also call this as the power set. Total number of subsets of P, which is nothing but the power set. Remember, we have done this in set theory. What is a power set? A power set is the set of all subsets of the given set. Okay, so 2 to the power the cardinality of the set P. So how many subsets we can have? 2 to the power 10. We can have 1024 subsets of P. Okay, so we can now devise a function. Okay, the function maps bottles of wine, okay, to the set of all subsets of P, or I can say the power set of P, where 2 to the power the cardinality of P is the power set. It is the power set. Let me not use cardinality here because that is something, is a number actually. 2 to the power P only. Let me use that. So where P here denotes the number of elements in P only. So where 2 to the power P is the power set of P. That means set of all subsets I can make. Because obviously we have a lot of wine bottles, but we have only 10 prisoners. Obviously, every prisoner is going to have more than one bottle of wine. Or I can put in another way, every bottle of wine. So if I show it to you, basically this is W and this is 2 to the power P. So every bottle of wine goes to a group of prisoners. Every bottle of wine is going to go to a group. Now group is not, this group is nothing but the subsets. These themselves are nothing but the subsets of P. I'm writing it more clearly. These are nothing but the subsets of P. Similarly, I can have more. And ... how many bottles we have? 1000 bottles. So every bottle is going to go to a subset, and repetition is possible. It's completely possible that, for example, the third prisoner is having the 10th bottle of wine, 15th bottle of wine, 27th bottle of wine, and so on. So basically, one bottle of wine is going to go to multiple prisoners. Okay, and these prisoners are a subset of P. So power set of P is nothing but set of all subsets I can make. And remember, what are the number of subsets you can have? 2 to the power P. Where P here is nothing but the cardinality, which is 10. Okay, so hoping all students have understood this mapping. Now, if you look at F of I, so I denotes the ith bottle of wine. I denotes the ith bottle of wine. And F of I will be what? F of I is a subset of P. That is subset of the prisoners who drink wine I. So suppose I say, guys, this is wine 1. then this will denote what? Subset of the prisoners who drink wine 1. Who drink wine 1. Similarly, this is wine 2. So what will this denote? This will denote subset of the prisoners who drink wine 2. Dot, 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 we have 1000 wines. So we are going to have every bottle of wine will be mapped onto a subset of prisoners. We have 10 prisoners. The possible subsets we can have is 2 to the power 10, which is 1024. Now you can see that the function is a 1-1 function. Every wine bottle will be mapped on to a unique subset of prisoners. Okay. So I can erase the initial part. I hope all students are simultaneously writing the solution. That is very important, that you write along with me. Okay. So erasing this part, I can now write that clearly the function f, is injective. That is, it's a 1-1 function. That is, every bottle of wine is mapped on to a unique subset of prisoners. Since, how can I say this, guys? Since you can see that cardinality of the set W is 1000, but cardinality of the power set. The power set consists of how many elements? The power set consists of 2 to the power 10, which is 1024 elements. Because P consists of 10 elements, so the power set of P is going to consist of 2 to the power 10, which is 1024 elements. So 2 bottles of wine cannot be mapped onto one unique subset. That is not possible. That means W1 and W2 both cannot go to the same group. Because you have 1024 possible groups you can make, but you have only 1000 wines. So every bottle of wine is going to go to a unique group. And I can say that if wine J is poison, I can write that if wine J is poison, then the prisoners in the set F of J will die after 24 hours. Suppose I say that wine WJ is the poison wine, then those people who are in this particular set who have consumed wine J will die after 24 hours. So basically, if I talk about the king needs to devise this function. The king needs to make this function, where every bottle of wine will be mapped onto a unique subset of prisoners. And from the death of one of the set, you can find out as to which wine was poisoned by reverse mapping. Okay, so hoping students have understood. So I can write this, guys. I can erase this part. So the main hurdle was to actually allocate a function, which we have actually done. This is the only answer for this question actually. Remember, this paper is a subjective paper. The PEB paper is a subjective paper, so you need to explain. Okay, so I can write thus, each wine can be administered to a unique subset of prisoners. Each wine can be administered to a unique subset of prisoners, and the exact subset of prisoners, that die after 24 hours will allow us to find will allow us to find out which wine bottle was poisoned. Which wine bottle was poisoned? Okay. So hoping all students have understood the solution to this question. Okay. So this was indeed a very interesting question. So now another way in which the king can do is the king can assign the function f. The king can construct the function f using binary representation of decimal numbers. So you can clearly see that the domain consists of the numbers from 1 to 1000. For simplicity, we can convert them into binary digits, 0 and 1, which will again be mapped onto binary digits in the set P from 1 to 10. Okay, but this is the main answer for the question. Okay, so hoping all students have understood this. This is where I intend to stop in this particular lecture. The objective of this lecture was to discuss with all students the second question for the PEB entrance for ISI 2021. In the next lecture, I will be discussing question number 3 for practice. I will be taking up question 3 for discussion in the next lecture for the ISI PEB entrance. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.